If you want the same kind of agent workflow on your own machine, check out conductor.com. Conductor works with the coding agents already in your current setup. It runs fully local, and I'll also show the open source repo and native coding agent screenshots later in this video. A tiny Zig CLI may have just solved one of the most annoying real-world problems in remote AI agents. Not prompting, not reasoning, not code edits, permission dialogs. Tommy D. Rossi just posted a demo of a tool called usecomputer, a CLI written in Zig that lets any agent control a computer, mouse, and keyboard. And the specific example is the part that matters. It shows an agent stack dealing with a macOS security setting, which is exactly the kind of ugly system-level friction that makes a lot of agent demos fall apart in the real world. That is why this is more interesting than it looks. This is not just another computer use clip. It is a demo aimed right at one of the hardest operational bottlenecks. A lot of agent demos look great right up until the operating system starts pushing back. The browser flow works. The terminal command works. The model knows what to do. And then macOS throws a permission dialog, an accessibility prompt, or a security gate in the way, and suddenly the whole workflow stops being magical. That is a huge problem if you want remote agents to be actually useful. Because real work happens on real machines, and real machines are full of annoying prompts, settings, pop-ups, and security barriers. The prettier the demo, the more likely it is that somebody cut around those parts. So when a post explicitly says the hardest part of controlling a remote agent is accepting macOS permission dialogs, and then shows a tool stack aimed at that exact issue, that deserves attention. This is infrastructure work, not cosmetic demo work. Let's walk through the actual clip. The post says this is usecomputer, a CLI written in Zig that lets any agent control a computer, mouse, and keyboard. Then it says the hardest part of controlling a remote agent is accepting macOS permission dialogs. That line matters because it tells you exactly what problem the clip is trying to prove. The footage shows a live desktop flow where an agent is handling a security or permissions setting on macOS. This is not just a terminal output or a browser click path. The agent appears to be driving the real desktop with mouse and keyboard primitives. And the stack is important too. The post says the demo uses usecomputer, Kimaki, and OpenCode. That means this is not one monolithic app doing everything. Kimaki is the Discord control layer. OpenCode is the coding agent runtime. And usecomputer is the desktop actuator that can actually move the cursor, press keys, and take screenshots. That modularity is a big deal. It means the breakthrough is not just one flashy interface. It is that the stack has separate pieces for remote control, agent reasoning, and desktop execution. Now here is the grounded version. The usecomputer README describes it as a desktop automation CLI for AI agents. It supports screenshots, mouse control, and keyboard synthesis, and it works on macOS and Linux. On macOS, the README explicitly says accessibility permission is required for the terminal app. That matters because it confirms the post is not exaggerating the general problem. Permission handling really is part of the core operating model. Kimaki's official repo describes it as Iron Man's Jarvis for coding agents inside Discord. It lets you control OpenCode coding sessions from Discord, with each channel linked to a project directory on your machine. And OpenCode itself is an open-source AI coding agent. So the stack shown in the post is coherent. Discord control layer, coding agent runtime, desktop automation layer. This is why I think the post matters more than it seems. The future of agents is not going to be won only by smarter reasoning. It is also going to be won by the boring infrastructure that helps models survive contact with real systems. Permissions, file systems, pop-ups, OS security, weird edge case UI. Those are the places where real automation either becomes useful or falls apart. And that is why a small Zig CLI can matter. If a lightweight tool like usecomputer makes desktop actuation more reliable and more portable inside open-source stacks, it becomes a force multiplier for everything built on top of it. The big lesson here is that agent progress is increasingly modular. One project handles reasoning. Another handles remote control. Another handles desktop actuation. The stack gets better when each layer gets sharper. Zooming out, this is exactly why orchestration matters. The agent future is not one giant magic model that does everything perfectly. It is systems made of components, memory, tools, runtimes, messaging layers, execution environments, and actuators. That is also why I keep bringing up ConductorOS.com and the Conductor OSS repo at github.com/tyrannyk06/conductor-oss. I'll show the repo, the native coding agent launch screens, and the current local setup on screen here. Conductor works with the coding agents already in your setup, and it runs fully local. This usecomputer demo is a great example of the same direction. Real agent systems win when their layers cooperate cleanly. Different project, same broader truth. The stack matters more every month. If you want more breakdowns like this, subscribe. And if you want an agent setup that works with all your current coding agents and runs fully local, go to ConductorOS.com and check the open-source Conductor repo. The next big leap in AI will come from systems that can actually survive real-world execution, not just ace a clean benchmark.